lesson on powertrain elements, and we're going to be covering both the chain and sprocket and the belt and pulley system. So go ahead and if you guys will start your page there. So let's take a look at some examples of belt and pulley drives. So this is just a very simple GIF to show you your driver and your driven pulleys, and notice how they have different diameters here. So this isn't like when we were dealing with pulleys in simple machines where you guys had just pulleys with a rope hanging over them. Let's see, like these lovely guys back here. This is quite a bit different. So this is actually using a closed, well, there's a single belt between them, and also notice how pulleys, they're going in the same direction. So pulleys, so pulley drives, pulley and belt drives. Okay, so when we have our two pulleys that are connected by a belt, kind of trying to draw the belt so that you can tell that there's a belt going around them, the pulleys are going to rotate in the same direction. So both pulley wheels rotate in the same direction. Okay. Put a little dot there for the axle. But the way that you set up a pulley system, you can actually have things going in different directions. I know it's a little tricky to see on here. I'm not sure that you'll be able to see it real well, but depending on if the pulley wheel is on the inside of the track or on the outside of the track, they'll be going different directions, and that's called a serpentine pulley. And we don't need to, I'm not going to make you draw that one out, but that is one to be able to identify where things are going to be rotating. So all of these that are on the inside of the belt, they'll be rotating one way. You can see that they're going counterclockwise, whereas these that are on the outside, they're all going to be going clockwise. And you might be able to tell that, but it's a little hard in this animation. So here's another example where depending on where the pulleys are going, you can see this one is rotating, I guess, because the orientations are 90 degrees, it's kind of hard. These two, it looks like they're rotating opposite, and I think these two are rotating opposite. So having those changing directions allows that for it to happen. This next example is called a cross belt transmission, which I couldn't find a good GIF to put in here. So, sorry, let me get that past the commercial and then drag it in for you. Okay, here we go. So this is an example of a cross-belted pulley, and I think you can see a little better here, especially because the teeth are going along the outside here. There's some little notches, and then over here they're going on the inside, and so you can see that those are going in reverse. And that's what we would call a cross-belt transmission. So that's another example of a thing that you can use. There's just an infinite way that these things can be utilized. Now with a chain and sprocket, the only difference here is that chain and sprocket, you're using a chain instead of the belt. So it's actually fitting into those teeth. And then, so let's just add same for chain and sprocket, not get too crazy with our notes today, but you can see in a bicycle how those are going the same direction. But we can have similar issues if we do this gears. Here gears are all on the inside, and so they're all rotating the same way, they're all rotating clockwise. Whereas here, the ones that are on the inside, those are rotating counterclockwise, and hopefully you can tell that this one is actually rotating clockwise. So counter on the inside and clockwise out here. Then these two are going together counterclockwise, and these two are going together clockwise. So depending on how you arrange your chain or your belt, you can make different configurations. This is an example of a pulley belt with teeth. And this is like, you would see this in your cars drive system. You're going to have actual pulley wheels that have little teeth around them, and then the pulley belt itself has teeth that sink in there, and so that actually allows for a little bit more grip and less slippage. Okay, let's get into the math of it. You'll find that the math is just as easy as the math for gear ratios. The only difference is that we're looking at this where the input and output are connected by either a belt or by a chain, but we're using the exact same equation. So pulley and belt gear ratio equations. So it's not really a gear, there's no teeth, so we can still say that these relationships, though, they're the same. So your diameter out over your diameter in, that ratio is equal to the angular speed in over the angular speed out, and the torque out over the torque in. So it's the same thing, we've just removed the number of teeth ratio because there are no teeth here, unless you're dealing with one that was, like this. Okay, so in this example, let's sketch this little example here. They've got this pulley. The diameter is equal to 2 inches. The RPM, or the angular speed, is equal to 30 RPM. And they're also telling us that the torque is equal to 18 1/3 foot-pounds. And this is connected to a bigger gear, or not a gear, a bigger pulley. I'm going to try to use like a fatter marker to make the belt between them. Can I see? Oh, so sorry. That was a while. You were probably getting really bored there. My apologies. Oh, yep, this marker's basically dead, sorry. I'll just use a pencil to kind of sketch it so that you can see that on the outside. So there's the belt going around them. And I guess we're assuming, because this is, okay, this says output, this says input. Okay, so let's go ahead and we'll label this as input and output. Gotta check, because sometimes it was different. Pen. There we go. So this diameter is equal to 6 inches. The angular speed is equal to 10 RPM. and then our torque is equal to 55 foot-pounds. Okay, so d out over dn is equal to omega in over omega out is equal to torque out over torque in, and we're going to go ahead and substitute. And we won't really need to solve exactly. We're just going to put those values in there and then kind of reduce. So for our diameters, we have 6 inches over 2. And then we have 50, sorry. Then we have RPMs, 30 RPM over 10 RPM. Remember, we got to flip the order because that's in over out. And then the torques are going to be 55 foot-pounds over, this was 18 1/3 foot-pounds. So it should be pretty obvious, especially looking at the 30 over 10 and the 6 over 2, that we could reduce this gear ratio to 3:1. So if we were to do, if it had a gear ratio, would be 3:1. So that's kind of the relationship here. All right, now let's talk about an example with chain and sprocket. I'm going to go ahead and leave this little space unaccounted for. Page 1 of however many, probably not too much. So here is sprocket and chain system. Okay. We're going to go ahead and sketch this one as well. All right. This little guy and this bigger guy, about twice the size. So I'm guessing that the ratio is going to be 2:1, just a wild guess. Let's see, this is our input. Our diameter is equal to 1.5 inches. Our angular speed is equal to 90 RPM. And our torque is equal to 60 foot-pounds. Our output, that is a diameter of 3 inches, an angular speed of 45 RPM, and a torque of 120 foot-pounds. Are you guys seeing a pattern? Because I am. And then I'll just do a little dotted line to show that this is a chain and not a pulley. Even though, like, we would have teeth here. Like, we could actually have number of teeth, but they haven't given that to us. We probably know that this one has twice as many teeth as this one, based on what we're seeing right here. But then we know d out over d in is equal to omega in over omega out is equal to torque out over torque in. And so that means we have 3 inches over 1.5 inches. We have 90, almost wrote 45 RPM over 45 RPM. And then we have a torque of 120 foot-pounds over 60 foot-pounds. Okay, so our ratio is 2 to 1 for this chain and sprocket example. Oh, where'd the number of teeth? Oh, I guess you can actually count these little guys going around. Okay, well, we'll fill that in. I must have missed that when I was going over this. So our number of teeth are actually, for the big guy, what was that, 22 teeth? And for the little guy, 11 teeth? Fair enough. So we can have n out, oh shoot, I should have written n out over n in, and that would be 22 over 11. There we go. Okay, now I got them all. I didn't take my time and make it as neat as I could have. I apologize. Okay. The final thing that I want to go over with you guys is comparing pulleys and sprockets. Okay. I'm not going to draw out this whole table right here so that you don't have to watch me just write, but I do want you to create this table. So pulley, sprocket, method of transmitting force. Transmitting or transferring is fine. And then the advantages and then the disadvantages. Okay, so I do want you guys to fill in this table with that information. So the pulley versus the sprocket, that is belt versus chain. Advantages of using pulleys is that they are very quiet, no lubrication, and relatively inexpensive, whereas with sprockets, there's no slip, and there's greater strength with the chain than with the belt. The belt's going to get stretched out, can tear, so it's more likely to break than the chain is on the sprocket. And then a disadvantage for the pulley is that it can slip. Now, in some cases, having the pulley able to slip could be a benefit because that's kind of its way of preventing breaking versus the chain. So it really just kind of depends which of those, if slipping is helpful or slipping is not helpful, what is it that you need. Some of course, the pulleys have teeth that you can use to help with this slipping disadvantage here. Sprockets do need lubrication, they're noisy, and they do have a higher cost than using the pulleys with the belts. Okay, so to summarize this lesson, we looked at the pulley and sprocket systems. They use the same formula as gear ratios. When you have gears and pulleys on the same side of a belt, those two, your input and output, will rotate the same direction as opposed to gears where the gears rotated in opposite directions. And main difference between pulleys and sprockets is they just don't have teeth except for the kinds that do. So, and we just went over this, so I don't think I need to go over that again. All right, that is it for learning about your powertrain elements.